Welcome to Crash Concepts, where the economy, energy, and the environment are explored. Up next, fresh ideas and insights into the factors that are driving the world and shaping your future. Presenting information you can't afford to live without, here's Chris Martenson.
Welcome to this Peak Prosperity podcast. I am your host, Chris Martenson, and as promised in an earlier interview, today we are going to discuss climate change with a well-known and widely published and cited scientist who also happens to chair the climate change thread at Peak Prosperity, for which he has my deep admiration for both the style and form of the conversation being held there. We are talking with Dr. Mark Cochrane today, who is currently conducting climate-related research in the United States, Australia, Brazil, and Indonesia that explores how climate change is affecting the characteristics and impacts of wildfires on ecosystems and human societies. He is also professor and senior research scientist at the Geospatial Science Center of Excellence, the GSCE, at South Dakota State University, and he holds a doctorate degree in ecology from Penn State University and a bachelor's degree in environmental engineering from MIT. Mark's Earth Systems Science research focuses on understanding spatial patterns, interactions, and synergisms between multiple physical and biological factors that affect ecosystems. This look at complexity is exactly what you need when you're looking at the economy, energy, or the environment, in this case, climate change. His interdisciplinary work combines ecology, climate science, remote sensing, other fields of study to provide landscape perspectives of the dynamic processes involved in land cover change. I've invited Mark on to share his expertise with all of us and publicly dig into the topic of climate change. Mark, thank you so much for your work on the site, and thank you for joining us today.
You're welcome. Thank you for having me.
Well, Mark, we hear a lot of discussion about climate change these days. What is your interpretation of the science?
Okay, well, that's a good question. To discuss climate change, you first have to consider what climate actually is. You know, we're worried about it changing, but we don't generally think about what climate is because we live in it every day. The standard answer is that climate is simply average weather over a long period of time, where 30 years has become sort of a de facto standard unit of climate time. It could be more than that, but generally we need at least 30 years to feel like we have a good measure on a region's climate. What climate really describes, though, is the average patterns of energy redistribution that form as the solar energy that strikes the planet moves from warmer to cooler regions throughout the years. So in any given year, the Earth gets a fairly consistent amount of solar energy, or energy budget, if you will. The energy doesn't arrive evenly over the Earth's surface, though, because the planet's a sphere, and it's spinning and covered with varying amounts of clouds, land, water, and ice. Okay, most people will be familiar with the blue marble photograph of the Earth from space that the Apollo astronauts took back in the 70s. Mm-hmm. So what we're seeing there is the sunlight that's reflected from the planet. So of all the solar energy that arrives, roughly 30% of it is reflected right back off into space. Therefore, it doesn't have any climate effect whatsoever. Okay, we can think of that as what I would think of as an albedo tax, which simply means that we lose some of our solar budget, and more of it if it gets shinier and a little less if the planet gets darker for some reason. That would be more clouds or less clouds, more ice or less ice. So of the remaining solar energy that arrives, maybe about 1% gets used by plants and algae to conduct photosynthesis and produce all of the food that supports every living creature on the planet. The lion's share of the solar energy, though, nearly 70%, gets absorbed by the oceans, the land, or the atmosphere and is converted from light into heat. All of that heat energy is what actually drives the climate of our planet. Okay, this heat warms the planet, it evaporates moisture, it creates weather patterns in the atmosphere and currents in the oceans that redistribute all that excess energy from one location to another. So this heat dissipates out into space as long-wave thermal radiation, both during the day and night throughout the year. You know, if we didn't have an atmosphere, our daily temperatures would be kind of like that of the moon, where days would be 235 degrees Fahrenheit and nights would cool to minus 243 degrees Fahrenheit. And the atmosphere, it just acts kind of like the glass of a greenhouse, where the sunlight can pass through easily, but the glass reflects back a portion of the heat energy that the planet radiates. So this greenhouse effect slows the rate of energy loss just enough to keep us at what we consider a nice, comfortable global temperature. It's kind of like a blanket does when it keeps you warm at night by slowing the rate at which you lose your body heat. The whole crux of climate change just comes down to the energy balance of the planet. If things are stable, where we have the same amount of imported energy from the sun and exported energy with the heat, then the climate will be fairly stable. It'll be balanced out. If we lose more energy than we gain over a period of time, then the planet would cool and we get things like the ice ages that we are familiar with in our past. So conversely, though, if we are gaining more energy than we lose, the planet will warm like it is doing right now. Okay, climate change science can sound incredibly complex, but there are, in fact, just 3 mechanisms that we could come up with that would cause the planet to warm the way it is. The first would be the sun could be getting brighter, providing a bigger energy budget. Okay, we have satellites measuring solar radiation very closely and have for decades. We know for a fact the sun is not getting brighter. We're actually coming out of one of the dimmest periods over the last 100 years, where we have these 11-year sunspot cycles, and we were at a major low in these cycles that was the lowest in over 100 years. We should have actually had global cooling over the last decade. Instead, we've had something that's been apparently more flat in terms of global temperatures, but a lot of energy is still accumulating in the oceans. The second way we could potentially warm the planet, if we were trying to, would be to try to make the planet darker. So thereby we would absorb more solar energy and reduce our albedo tax. So it's the difference between if you're out barefoot and step onto white concrete on a hot sunny day, not so bad. But if you step onto the blacktop, the asphalt, it's very hot on your feet. So if we get darker, we would absorb more of the sunlight and turn it into heat. Okay, we've been measuring the energy reflecting back off the Earth for decades as well, and we know for a fact that the planet is not getting darker. If anything, it's getting brighter due to the amount of atmospheric haze that we've created through pollution. The third possible alternative for warming the planet is that, for some reason or other, the rate of energy dissipation, the thermal energy leaving the planet, is slowing down. We're not losing it as fast as we used to. This occurs because of changes in the atmospheric concentrations of the so-called greenhouse gases, things like carbon dioxide, water vapor, methane. Okay. When we look at the measurements we have, in fact, the rate of change corresponds very closely with the observed rate of the increase of those gases and the warming that we're experiencing. So measurements, theory, and observations all support one another. So anthropogenic greenhouse warming is the only scientific theory that accurately explains what is occurring. We've had over 100 years of scientists trying to prove this theory wrong, and there is close to unanimous scientific agreement on this as you're ever going to find, with at least 97% consensus among scientists who actually work on the subject. Okay, when I mention anthropogenic greenhouse warming as a theory here, I mean that it is a theory that's on par with the theory of gravity or evolution. Scientists are still investigating the nuances and implications of climate change, and the modeling of potential future climate projections is active and a continually developing field of study. But the existence of ongoing and geologically rapid global climate change is as settled as science gets. There is no remaining scientific debate about the subject. The scientific discussions are only about the rate at which the warming is occurring and what the implications are of this climate change as it happens.
So we're putting this carbon dioxide into the atmosphere as one of the primary components of the greenhouse gases. It's measured in parts per million. Is it really? Is it? How effective is it at trapping that thermal radiation? So I assume there's this long wave infrared radiation. It's trying to get back out into space. It bumps into a CO2 molecule, which absorbs it, converts that back into heat energy, and becomes an active molecule bouncing around. And these are measured in. I guess we got close to 400 parts per million this year. How effective is CO2 at trapping this thermal radiation?
Oh, well, it's very effective, but it's only part of the equation. What you've described is exactly right. We have these thermal waves of heat that go up through the atmosphere, and instead of being this nice clear atmosphere for sunlight, it's a slightly opaque, a hazed atmosphere for those wavelengths of energy. And things like carbon dioxide or water vapor will occasionally capture one of these waves. The whole matter comes down to when it releases that energy again, what happens? There's a 50% chance it releases it up towards space and a 50% chance that it sends it right back down to the Earth. So an increasing percentage of the energy that's being released is basically bouncing back and forth in the atmosphere for a little longer. should mention that, water vapor is the strongest greenhouse gas we have. It has gone up about 6% in the last 3 decades because of the amount of warming. So we have greenhouse gases like CO2 and nitrous oxide and such that warm the planet, but as we warm the planet more, we increase the amount of water vapor that can be held in the atmosphere. As we increase the amount of water vapor, we warm the planet even more. So the CO2 level is a bit like a thermostat. It starts the process, but it is not the actual main culprit, if we will, in causing the warming.
Right. So lots of water vapor. It's actually we all know water is very, very good at conducting heat and storing it and all sorts of things like that. We're here at 400 parts per million. Historically, when was the last time we were at this level, and where are we going in terms of temperature as we cast forward and think about going to something higher, 420, 430, 440? Is there a direct relationship that we can sort of map out that's reasonably certain, or is this where a lot of the controversy still lies?
Yeah, there is a fair amount of controversy just because we don't know how fast things will occur. We have some idea more if we were to, say, go into an equilibrium state. If we could say we're going to hold at 400 parts per million, then we're basically saying that we are going to push ourselves 2, 3, or more million years into the past in terms of a climate analog. As we increase the levels even more, though, we push further and further. So if we keep doing business as usual, where we try to exponentially grow the amount of fossil fuel emissions, we're talking about putting the climate back 20 to 30 million years. Now, how do you really get there, and what happens in the meantime are the issues. We know that if we were to go back, say, 3 million years, like we're planning right now, if you will, that almost all ice on the planet would melt. It wouldn't melt overnight, though. It would take centuries, but we would have a recipe for increasing sea levels by 50 to 70 meters. As we push beyond that, we are really entering into what we call no analog futures. We don't have any past conditions that simulate what it would be going on, so we get more speculative on what it would mean. The larger concern is not so much what level it will be as just how fast we're getting there, because everything on the planet has to adjust to these changing temperatures.
Well, let's talk about that adjustment process, because there's another facet to this story that I've been following, which is the idea of ocean acidification. And as I understand the process, CO2 in the atmosphere exists in equilibrium with CO2 in the ocean, so it's dissolving back and forth from the aqueous to the air environment. And so we're increasing the amount of CO2 in the ocean as well. That, in turn, some of that CO2 turns into a form of acid, and that starts to drop the pH of the ocean. Now, the ocean's got as I understand it, very, very sensitive pH conditions for certain types of phytoplankton and calcium carbonate-wearing animals of our lives, the snails, the bivalves, the other things like that. What do you know about, where are we with the ocean acidification story as potentially something that could be as disruptive as weather pattern changes, which we'll get to in a minute?
Yeah, this is kind of the poor relation to what we think of as climate change. I call it the other CO2 problem.
All right.
No, it is quite serious and under-recognized as a serious problem. We look back through, history. We have, little air bubbles trapped in ice going back over 800,000 years, and we were never above 300 parts per million in terms of CO2. Well, now we're bumping up against 400 parts per million. What happens is just what you said. We emit all this carbon, but it doesn't all just pile up in the atmosphere. About a quarter of it gets taken up by vegetation, and another quarter of it ends up equalizing the partial pressure in the oceans. So only about 50% piles up in the atmosphere right now. However, as this sink occurs in the ocean waters, it basically dissolves in the form of carbonic acid. So everything that lives there is now living in something that's more and more like living in a soda bottle instead of normal waters. So things like all the phytoplankton that require calcite to form little shells and structures are losing that ability, such that through many of the types of phytoplankton and coccolithophores and other organisms, their shell densities are dropping by 30 to 40% at the current levels. As this continues, they will have an increasingly harder hard time forming these sorts of bodies. So, I do not think this necessarily means that we will have a complete collapse, if you will, of photosynthetic organisms in the oceans, but we will be selecting for different types more and more over time and causing a lot of damage. This is also one of the foundations for the whole food web of the oceans, either on the phytoplankton or on the pteropods, little sea snails that are abundant in polar oceans. They are also having trouble making shells, and therefore we won't have as many. We don't think that's important, but that's the base of the food chain for things like salmon or whales and seals. Krill are having a hard time making shells, so they are one of the main food sources for much of the ocean's creatures. If we look in the future right now, by 2050, the most recent science I've seen shows that the level of ocean acidity could basically make shell-building organisms a thing of the past for, say, much of the West Coast. So, put an end to things like the oyster industry all along the Pacific Northwest. They're already having serious problems, and the problems they're having now is from deep ocean waters that are washing up that are basically representing the carbon levels that were in the atmosphere in the 1950s and 60s. So even if we were to somehow stop increasing levels right now, this problem would worsen for another 50 years.
50 years. So I want to talk about the pace of change, because that's a concept you brought up before. Certainly the world has cycled through warmer periods and cooler periods in the past. It's had carbon dioxide go up and down, but usually, I guess in the record, you would say these changes happened over hundreds of thousands of years or tens of thousands, and it seems like we're doing it in, 150 years. But really it's the pace of carbon dioxide addition to the atmosphere is, as I understand the doubling process and exponential functions, it would seem that, I'll make a guess here, probably in the last 30 years we've put as much in the atmosphere as we put in all the years prior. Just taking a guess at that. But so if you have got a good number on that, let me know. But it's the pace of change that we're worried about here, right? Because ocean organisms could respond over time. The selective adaptations and pressures would allow some to arise where others were now absent. But if the pace is too quick, you are talking about the potential of a big a gap in the overall phyla and flora and fauna and all the other things that we're seeing out there right now in terms of complexity and diversity, right?
Yes, it is just that. It's how fast things occur. Put things in perspective. Business as usual, if we keep this up, we're looking at potentially warming the planet by somewhere between 4 and 6 degrees Celsius by the end of this century. Now, trying to put that number in some perspective is always difficult. These big average numbers don't mean much because, you might have experienced that much temperature change since you get up this morning. When we talk globally, though, 5 to 6 degrees Celsius change is the difference between the depths of the last ice age and what the planet experiences today. Now, coming out of the last ice age took over 1,000 years, so we had 10 times as much time for that amount of change to occur. In terms of CO2-driven type climate change, the only analog we really have is about 30 million years ago, the Paleo-Eocene thermal maximum, where, for a variety of reasons, we had a massive carbon release into the atmosphere that is equivalent to what we have been doing over the last century, but that, again, took about 1,000 to 2,000 years to occur, so it's not a direct analog. We are doing things faster than was done at that point. So we are creating huge changes that will take centuries to play out, but they will cause an increasing number of problems for us right now. So yes, in the oceans, for example, as we increase this and increase it rapidly, things that cannot adjust quickly enough will diminish considerably. To my knowledge, the only thing that seems to be favored by this change right now would be jellyfish.
And they're doing quite well, I understand.
Oh, yes. Reproducing well.
Excellent. Yeah. Let's. So I want to talk about then, how most of us experience climate is in the form of weather. Here in New England, it's been very steamy for a while, and that's because the jet stream, as I understand, has formed kind of an unusual loop for this time of the year. It's looping down very, very far, so that last week, I believe Texas had cooler temperatures than I did here in Massachusetts, a bit of an oddity. And it was just last year the Midwest was in a drought, and this year there's too much rain to plant in many areas. So what's the relationship, as far as we understand it, between climate change and weather stability? And I care about stability because we've We've settled around areas which have rainfall that's predictable and good soils that are formed in the process of that. The point being that weather stability means food stability, so there's a direct connection for me. But how do we start to put weather and climate together?
Yeah, well, it's another great question. One I've actually got people working on right now, trying to put numbers to some of this, because when we hear all of this, we get these big averages, like 1 degree C warming, and that means absolutely nothing to anybody, and you cannot adjust or adapt to 1, 2, 3, 4 degrees change of temperature because it doesn't translate into what happens where you live. So, the models going forward are difficult because you have to bring down the scale to a level that's meaningful. But we don't need models. We can look at what's just happened in the last 100 years. We have plenty of weather records. And what we see is that, yes, the weather seems to be getting more variable. That kind of fits with what most people have experienced. So on average, things may not have changed so much, but for example, where I live 2 years ago, we had the Red Cross in town because we were flooding. We'd had twice as much rainfall as had ever been experienced here in over 100 years. Last year, much of the state was at drought levels that were below the Dust Bowl. This year, our season is delayed well over a month because it was too cool and wet to plant. So we have general variability going on, but we do also see some of these patterns that seem to be forming. So what we think is happening with this is we have these large-scale atmospheric movements. So we directly heat areas of the equator more so than the poles. We get a transfer of air and heat going north, creates these large cells. We have the Hadley cell down to about 33 degrees latitude. Then we have a kind of a mid-latitude cell, and then we have a polar cell on top of that. Well, right now we are melting the Arctic sea ice at a phenomenal rate, far beyond what was being predicted even a few years ago. And what this means is that more heat is piling up in the polar regions than we would expect. Well, why is that important? Well, as we do this, we change the thermal gradient between what the energy level is in the polar areas and what the energy level is down at our temperate areas, like where you live. Mm-hmm. And so what happens is now the boundary between those two gets a little fuzzier. That boundary tends to be formed by what we call the jet stream. As we reduce that temperature difference between those two areas, the jet stream slows down. It's not as strong, and it's kind of like a river, and it starts meandering, making these big, deep meanders far south and far north. We experience cool weather or hot weather, but it extends far to the north as well as to the south. So there's a reason why in science, we don't really call it global warming. We call it global climate change, because although the planet is warming, what we experience is an increased variability of the weather. Sometimes it'll be cooler, sometimes it'll be warmer. On average, it'll be warmer, but we don't live the average. We live whatever happens day in, day out. So with these big meanders, what can happen is it allows a lot of cool polar air to pour down in some regions, but it allows a lot of tropical air to pour northward or in other regions. And these patterns can become effectively stuck, blocking patterns, such that they can stay in place for weeks or months. So we'll have things like a winter where it's freezing in Europe and we're roasting. A couple of years ago, we had no frost from February on, which is ridiculous for the northern plains. But these changes, they're not going to be the same year in and year out. One year you may have incredible warmth, the next year you might have incredible cold. So everything we do is premised upon this idea of stability. Like, you got up this morning, you probably didn't throw on a winter coat. Why? Because it's July. You know it's going to be warm. It's just a question of how warm. Well, everything that grows out there, it basically grows there because, on average, it's fairly stable and dependable weather. But as the weather becomes less dependable, less stable, it creates a lot of stress in all of the ecosystems.
I noticed that very personally. Last year was a very dry year. We got 0.04 inches in April, which is a really important time for insect formation and hatchings. And so we had a really miserable insect hatch, which I actually didn't mind as far as the mosquitoes were concerned. But over our back field, there's a bunch of bobolinks that live there, and these are wonderful birds, great melodic sounds, and they live on insects. And they moved in their usual nesting pattern and stayed about a week and then left. because there was nothing there for them to eat. It was the first year that we'd seen them just absolutely go somewhere else. I don't know where they went, but that was, to me, was directly because of a very anomalous year where we had 0.04 inches of rain in April and very above average warm temperatures. And then this year it's been almost the exact opposite. Very cool, very delayed, very wet, all the way up through mid-June. So we say, the old economist joke, if you have one hand in boiling hot water and one hand in ice water, on average you're fine.
Yes.
So what you're saying is that even though we're experiencing something like an extra Celsius degree of increase, what we're going to experience is wider extremes that on average probably still don't look that bad, but it's the extremes that unbalance all sorts of situations.
Yes, and that's one of the things we're working on now is looking at, say, the last 100 years of climate and bringing it down as fine as we can so we can say something about different regions. What we see is interesting, though, in that even the variability that is occurring is not the same everywhere. It's not that everywhere is getting more extreme. Some areas are getting more extreme on, say, heat, but not so much on cold. Other areas are getting both extremes. They're getting both more likely to have extreme heat and more likely to have extreme cold, which doesn't seem to fit with the model of global warming per se. Other areas are actually becoming seemingly more stable. They're more likely to have what we would think of as normal weather. Now, there aren't that many, but some areas are. Mm-hmm. So there's a reason people are confused about this whole subject, because not everybody's experiencing the same type of change. If you go further north, though, and they're not so doubtful about it, because as you go north, we get polar amplification. They're seeing dramatically warmer temperatures. In other regions, not so much. So it's not the same type of change everywhere, but yes, what you're talking about is the way we are seeing it. There's the average, and my students know I'm not one for averages, because the averages hide so much information. Mm-hmm. I mean, would you create the average shoe size and then sell it to the entire planet? It wouldn't make any sense. But that's the way we talk about climate change. We give these average numbers of change that really do not tell us how that change will show up in our lives.
Well, let's turn now. I want to talk about the IPCC and how it relates to climate change science. I know that in the American press there's been a lot of controversy and things said back and forths, and I feel like can you bring some clarity to this conversation for us and just talk to us about what it is and what it does? Yeah,
the IPCC, or Intergovernmental Panel on Climate Change. This is kind of the big bugaboo for climate change. It's a favorite target of deniers or those who lambaste, the findings as being alarmist or radical or somehow agenda-driven. It's a good question. How did this supposed rogue organization arise? Okay, it's currently under the United Nations and such. I think most people would be pretty surprised to learn that the IPCC was initiated in the late 1980s by the administrations of President Ronald Reagan and Prime Minister Margaret Thatcher, who were hardly radical environmentalists. The intent was to forestall self-appointed committees of scientists from making what they considered alarmist statements about climate change. So the IPCC was created to be the utmost authority on climate matters by bringing together scientists from around the world to take comprehensive looks at all of the science. The IPCC does not conduct any science. It doesn't study climate change. It just takes all of the climate change studies that are out there and tries to condense them into one giant report. It was designed effectively to be inefficient, unwieldy, and conservative in its outcomes, because we need 100% consensus of all authors for everything that is reported. Now, having 100% consensus on anything is difficult. It's slowed down because we need representatives that have to be appointed from every single government in the world. It's more than 130 countries. The authors have to go through repeated rounds of report drafting to reach consensus. So the science that's reported is the most conservative statement possible. It's not alarmist. This is as the best case scenario, basically, that we could expect. The scientists who serve on these panels and do a lot of work don't get paid for any of this work. They have to volunteer their time. Okay. The last report in 2007 was about three volumes, roughly 3,000 pages of condensed research findings that almost nobody but masochistic scientists like myself read. Okay, the political appointees then get to edit what is the all-important summary for policymakers, political appointees, not scientists, go through that document and argue literally over every single word. Individual countries can hold the process for days until they get what they want. So in the last round, in 2007, at the behest of China, Saudi Arabia, and Russia, certain figures that were considered to be alarming were deleted, and the wording was changed to state the scientific confidence that anthropogenic global climate change was occurring to be less strong than the scientists indicated. So why would they do that? Well, currently China is the largest consumer, and Saudi Arabia and Russia are the largest producers of fossil fuels. So there's a political agenda out there, but it's not the one most people think. If we look at how it's constructed, Dr. Pochrane, the chair of the IPCC, is a favorite target of those who, want to deny climate change or land-base the IPCC. So it makes you wonder, how did this radical get to be in charge of it? Well, back in 2002, our own State Department in the United States refused to renominate the highly regarded atmospheric chemist Dr. Robert T. Watson, who had headed the IPCC since 1996. His views on emissions control were considered too threatening by energy industry lobbyists. So therefore, at their behest, then-President George W. Bush pressed for and got Indian engineer Dr. Pochrane appointed as a more palatable chair for the IPCC. So it's ironic to me, at least, that the same groups that design and formed and continually meddle with IPCC don't like the message that they're getting from it. The IPCC soldiers on, remarkably effective, and it's going to be coming out with at least the initial reports in September of this year, after reviewing about 60,000 scientific papers on climate change.
Are you 100% consensus? Really?
Yes.
I can't get that with 3 other people in the room. I don't know how that would be done.
Basically, they wear you down because it goes round and round and round until they find some wording that everybody can agree to accept.
So it stands to reason, particularly on the last stage of that whole thing on who writes the summary, being that they're political in nature, that this is really, there's going to be a lot of defense of business as usual. There's a very strong, obviously, component from the political side, from the corporate side, from even the cultural side to just keep the status quo cooking along. So, no pun intended. But I assume that, yes, as you say, the IPCC is probably going to be putting out extremely conservative or non-alarmist views on this. And that should be trackable, right? So the projections on sea ice that we're familiar with that have been badly whiffed upon by reality, were those projections the ones that came through the IPCC process?
Yeah, well, there's a couple of things going on. One is, because the process is so cumbersome, the actual cutoff date for the science that's included is usually about 2 years earlier than the actual publication date. Otherwise, they would never be able to finish. But the other is that, you may have some results that point to more recent findings that may be more concerning, but they'll be downplayed in terms of the changing amount of sea ice. Obviously, the models that were in place and the knowledge at the time definitely underestimated what was going on. Sea level rise is the other major one that was really missed. The last report was talking about maybe 50 centimeters of rise by the end of the century, and literally within months, it was pretty clear that we were looking at least 1 to 2 meters of sea level rise. So they're off by a factor of 2 to 4 there. That's because they were providing the conservative view of the science that was available up to the date when they cut off what was considered.
Well, this all speaks to the idea that these sorts of projections are extremely difficult to come up with, because this is not just a nonlinear system, it's multiple nonlinear systems interacting with each other, how much is being reflected back, whether warming increases more of this to come out of the ground or that, or other changes. So there's a lot of variability in this. We're learning as we go. But what would an individual do who's concerned about climate change, and how would they meaningfully prepare for or foster greater resilience if ultimately they feel uncertain about their ability to project what the changes are going to be and where they live? How do you begin to grapple with that?
Yeah, that's another great question. It's one that countries, cities, communities, people everywhere are having to wrestle with. And there's a reason we call them projections. Nobody tries to predict what will happen because there are too many variables. The biggest variable being how much will we continue to pump into the atmosphere. If you don't know that, you really can't try to predict. But you can project if we do certain things like business as usual, keep doing what we're doing, or if we do a best case scenario where we all try to go to green energy, we can kind of bound the problem. But I've been asked time and again and kind of danced around it, what can you do? How do you prepare for climate change? I've hesitated on that because it's, basically it's a hard subject to contemplate and difficult to encompass. With most aspects of climate change, I can simply relate the accumulated knowledge or the state of our understanding that science has at this time. So I can just tell you basically what's been reported in the scientific literature, and I'm covered, so to speak. As a scientist, you try to make sure that your sources are firm. As we go forward, though, I don't have that kind of literature to work from, so I'll talk about it here, but what I'm going to be talking about are basically the speculation about what will happen based on everything we know as we go forward, or what is already happening that we can actually see occurring. So climate has been remarkably stable, as we talked, for about over the last 10,000 years. This encompasses all of recorded history since we started agriculture. Through all that time, from the medieval warm period to the so-called Little Ice Age and everything else, the global temperature has been plus or minus 1 degree Celsius of a nominal mean temperature. Okay. Currently, we are proceeding outside of that range. In the lifetime of Homo sapiens, we have never experienced the warmth that we are currently on track to experience. So we do not know how this will work. We're going boldly where no human cultures have ever been before. Now, being able to change the temperature of the planet by 1 or 2 degrees Celsius within 100 years is astounding. And the current apparent trajectory of 4 to 6 degrees that we are on is completely unimaginable. Okay, so, scientists look at this with some horrid fascination because this is a sort of thought experiment we never thought could take place in reality. We're effectively terraforming the planet right now. We and all of our descendants are going to be guinea pigs of this experiment for the centuries to come. So if you have concern about these things, what do you do? Okay. Right now, I know I have concerns about the terrible debts that we're leaving for our children through our spendthrift ways. Well, we also have a giant climate debt that we've created. We've warmed by 0.8 degrees Celsius, but we've already placed 0.8 degrees Celsius in the pipeline, so to speak. We could not stop it if we wanted to. It's already there. The Earth now stores more than 25 times as much heat energy as we release from all of our energy uses each year. And that rate grows each year and will persist for centuries after we stop increasing the level of greenhouse gases. So just as increasing amounts of the energy can be used to stimulate economic growth, the increase in the planet's energy budget increases the types and amounts of weather patterns that move energy from one place to another. So if we look at things like financial collapse, that would be awful, but it would probably be resolved in about a decade. When we look at resource scarcity, that's something that's going to plague us for maybe a century or more as we adjust technology and our expectations and the populations. But with climate change, we have the equivalent of changing gravity, evolutionarily speaking. Literally, every living thing depends upon it. And so this will be the challenge for the next millennium, at least. That's 1,000 years. Okay, we can't make it better, but we can make it much, much worse. Now, this is where we get stuck a lot of times. What can you actually do with this? So what can you do to try to prepare? I'll try to provide some idea of what may occur and some practical things you can do. First, what I say is prepare for more. More variable weather from year to year and day to day. More flooding, more drought, more heat waves, more fires, more storms, more pests, more pathogens, more starvation, etc. Okay. The thing to realize is climate change is not an event. It is an amplifier of events. So in military jargon, it's a force multiplier. Nothing new is happening. Everything is just going to happen more frequently and severely than it used to. Every year, climate change will turn things up a notch, and all sorts of things, from droughts to storm surges to other weather events, will get more widespread or severe. This basically acts as a growing tax on capital, resources, and lives that will get extracted every year from the world economy. The estimates out there now is it's costing about 1.6% of global GDP due to these sorts of events. So you can bet these things are not included in any of the economic growth models right now. Okay, whether we like it or not, every year that we fail to act to diminish global emissions, we're voting for an environmental tax increase. So climate change is not a risk that we run, it's a chronic condition that we need to manage. So how is this going to show up? One thing I say is, you might want to consider heading for higher ground. If you live anywhere near the coast, you should be very aware of what your elevation is above sea level. as Hurricane Sandy showed, you don't need to be at sea level to be damaged by rising sea levels. You just need to be within reach of the storm surge that comes with a given storm. And that reach is going to grow every year. Until now, the federal and local governments have blissfully or even willfully ignored increasing risk of flooding. So just take a look at what's happened in New Jersey, New York since Hurricane Sandy. There's a new federal advisory flood map that's been generated to reflect current reality. Why should somebody care? Well, because now you have to raise your home above the level of the floodplain or face thousands of dollars in extra flood insurance costs. That can be up to $30,000 a year for a home. You don't have a choice. They're taking away the subsidy that most people didn't realize they were getting for flood insurance. You either have to pay to place your home on stilts, or you're going to hemorrhage money to insurance year after year, and many people can't afford it. If you decide to move up in the world, so to speak, then try to plan ahead and put your house up an extra 1 to 2 meters, because that's where the ocean levels are going. Coastlines are going to suffer in terms of property values, and they're more likely to be abandoned due to high insurance costs long before the high water level gets there in most cases. And people may blame FEMA or the insurance companies, but it's simply a reflection of the reality that sea levels are rising, and it becomes a statistical fact that more frequent flooding will occur. So plan on that. If you think you're okay just because you live further away from the coast, you should think again. One of the strongest signals of climate change around the world has been the growing intensity of rainstorms. You don't necessarily get more rain, you just get it a whole lot faster. What this means is that all of our current drainage systems are out of date. They can get overwhelmed under different storms. So places that never flooded will start to flood. And places that occasionally flooded will flood more frequently. 100-year flooding events that are expected every 100 years are now becoming decadal events in many places. If you look at Fargo, North Dakota, they've had major flooding in 4 of the last 5 years. In the last 10 years, they've had so-called 10-year floods every 2 years. 50-year floods have occurred 3 times in the last 10 years. So they're now proposing to build a $2 billion, 36-mile drainage canal to fix the problem. So if they do that, that's great for them, but what it's going to do is just magnify all the downstream effects for Grand Forks and Winnipeg up in Canada. What you can do, well, for one thing, check your insurance. If you do not have specific flood insurance, then most policies will not cover flooding if it comes over the ground versus through your roof. So if your roof blows off and you flood, you're covered. But if either a river or something else backs up and flooding comes in through your basement window, you will not be covered in most cases. If you have sump pumps or such, make sure that they're on your critical load for backup power. I personally experienced this. I put in a generator where my house was, and it saved my butt once, and I'd already been flooded once. If you don't have sump pumps, consider installing them unless you have excellent drainage. The flip side of flooding is drought. And I think of this as, dig deep. If you have a water table well, make sure it's deeper than you think you need, or as deep as you can get, so that you will have water even in the low water times. Okay, if you live in an arid region, be cognizant that more and more of the perennial streams will actually become seasonal in nature. As that water table drops, those streams will go away. If you live in much of the mountain west of the U.S. or any other region of the planet that gets much of its water supply from either melting snowpacks or glaciers, that's places like much of China, much of India, near the Alps in Europe, all the Andes of South America, then expect your water to be becoming your water supply to be less certain. So with melting snowpacks and glaciers, the amount of water available in a region is diminished. As it gets diminished, there's going to be more tension around who gets that water. So it would behoove you to have more water storage capacity. So within the next 1 to 2 decades, there's going to be acute water shortages occurring in many parts of the world. Okay, this will lead to everything from rationing to wars. Okay, the more insecure your supply is, the more storage you need. Plan on crop failures, whether it's your garden or world grain stocks. Okay, expect the yields to be more variable from year to year, with an emphasis on reduced yields. Okay, having floods one year and drought the next may average out to be normal, but crops don't grow during average weather. They grow in whatever day-to-day weather occurs. So how can you adapt? Well, one thing you can do is plan on more variety. Plant cultivars that are cold and heat tolerant, drought and water tolerant. Don't try to optimize your annual yield for a given year. Hedge your bets by planting to improve your average annual yield over time. In terms of home food storage, planning for climate change is simply means adding more cushion to your supplies under the assumption that you could lose a year or two of crops. Plant for the future. Knowing what grows well in your area is not enough anymore because that knowledge is becoming increasingly dated. Plant hardiness zones have recently been updated again in the U.S. to reflect more current climate conditions. They will keep changing decade after decade. I'm told that now you can grow olives and lemons on Vancouver Island if you choose your location carefully. So keep experimenting with new crops and cultivars from warmer climes in sheltered areas, and then you can expand their use as conditions allow. You can adjust some of your cooler weather crops similarly to less exposed or in the northern hemisphere on northerly aspects. Okay, expect new challenges from pests and pathogens. Okay, being able to grow new things like lemons and olives is great, but you should remember that if something new can grow on your soil, then so can every pest and pathogen that currently feeds on it wherever it is now growing. And build accordingly. If you have the opportunity to build a new home, be keenly aware of drainage issues, insulate and plan for energy and thermal efficiency, have a plan B for air conditioning. Planning ahead can be as simple as just making sure that you have screens for your windows or mosquito nets for your beds. If central air conditioning isn't a possibility, you're going to have to do something else. The risk of heat stress is growing in many places and is a major health problem, but health threats are more likely to arise from insect-borne diseases. So we have things like dengue that's now in France, malaria in Greece, West Nile going across the United States, Lyme disease is now up into Newfoundland and Canada. Globally, dengue is the most serious threat that's spreading rapidly in countries throughout the world. Malaria is also spreading. So if we don't have active management, malaria could return across Europe, much of the United States, as well as eastern Canada and northern Australia. It's not so much that climate change is opening the new niche as we've cleared out that niche, and if for some reason we can't maintain our ways of trying to keep those diseases from returning, they could spread rapidly over large areas. This goes on and becomes like a litany of doom. So, one last thing I would say is just breathe. Contemplating the implications of climate change can strike you much like the crash course did for me. That sense of doom. Oh my gosh, what do we do? Yes, many things will change and we'll have to adapt how we live. However, just because the challenges I've listed will continue to grow, they do not constitute a sudden catastrophe for the planet or human societies or you. More and more of the planet will be visited by increasing levels of environmental problems as the years pass. It's not suddenly going to arrive one day in the future. It's already here, and it's just going to be central to the rest of our lives and the lives of every generation from now until our great-great-grandchildren. Climate change will not destroy civilization like some dinosaur-killing asteroid. It will function more like death by 1,000 cuts, with increasing amounts of resources and capital diverted to climate adaptation and reconstruction activities. Things like bridges will wash out much more frequently, and we'll have to rebuild them. Wise people would be actively trying to stop the bleeding. Unfortunately, humanity does not seem capable of such wisdom, because as in the recent rebroadcast by Dan Ariely, he points out that climate change is just too uncertain, too slow, too nonspecific, and too intractable to register as a threat requiring immediate and costly action for most people. People are apparently as hardwired to make irrational decisions about the future climate as they are about money. So as an individual or a community, you cannot stop or even slow climate change, but that doesn't mean that you are helpless. You can plan ahead, you can adapt, and you can stock up on Band-Aids for all the economic cuts and abrasions that are coming.
Well, in Chapter 19 of the Crash Course, I noted that there were going to be multiple calls on our future cash flows and climate change and uncertainty around that is certainly going to be one. I mean, all it takes is one major crop failure, and it's a very expensive proposition. Sandy was a very obvious expensive proposition, but really it's the larger changes that are going to be super, super expensive. A large drought has an incalculable sort of expense to it, but it's very high. And I've started doing a lot of the things you said in my own personal life. So when I had a chance to put up a new building, I over-insulated it under the principle that heating and cooling it was going to be easier in any circumstance. When I'm planting cultivars now around my house, I'm really looking for ones that are very robust, that can deal with a 70-degree March and no rain in April, as well as they can deal with a late start till June. And it's there's just very hard to predict how things are going to react to these different swings. It's been a learning experience for me. And I'm glad it's just been a learning experience. When I talk to local farmers, it's been extremely expensive and difficult and consuming. And so it just feels like a constant battle where the terms of the battle are becoming the engagements are rising rather than diminishing. It's not even as simple as saying, well, now we've worked out hardy cultivars and let's go. It just seems to constantly shift. So we're just going to have to deal with that, which just means more and more resources towards managing our increasingly chaotic world around us rather than just coasting through it. So a lot of challenges coming up, and I know that we see a lot of young people very concerned about this, and people trying to figure out what they can do. And one thing I could direct people to is if you want to learn more about this very deep subject and you want to have a really nice reasoned conversation around it, you could start with the Definitive Global Climate Change thread, which is in our forum areas at Peak Prosperity. It's 1,400 comments long. Mark, is there any a place you could direct people to that in there, or is there a summary that's existing that been gathered at this point?
No, we don't have anything that kind of summarizes the whole thing. At one point, we're trying to have someone help create an index. There's, starting out just at the beginning of the thread, some of the early posts more or less lay out the general issues. But what I look for in there is just, questions from people. It doesn't have to be highly technical, scientific questions. It's just, what is happening and what is occurring. And if we've already covered it, we can try to direct people to those posts. And if we haven't, I'm happy to discuss it. And there are several other people that have been very good about posting very informative points of view on many aspects of climate change. So it's as much a support group as an information source.
Yep. Well, I very much ascribe to and was influenced by Dan Ariely's views, which you mentioned, on how it is that people will, through a process of insight, confront certain changes of behavior and other things like that. And unfortunately, as you mentioned, climate change itself is poorly suited to interact well with our human wiring. Our DNA blueprint seems wired for other sorts of threats more elegantly. And so I've come to the conclusion personally that climate change is already afoot and it's happening. I can't possibly predict how, what, where, when, or things are going to unfold, because the local mileage is going to vary hugely in this story for all sorts of reasons that are as yet unpredictable. And so it becomes a story then of figuring out how to manage within that. But certainly I think some trends that can be extrapolated that are useful is to say, well, reasonably certain this is just going to cost us more money over time. It'll be one of many things that's going to be demanding our resources, our attention, our best and our brightest. So that's just certainly a trend that I fully ascribe to at this point in time. Do you find that is that a trend? Is that the way you see it, or is there another way that people can adapt to this at this point?
No, I mean that's basically it's sort of like when we look at peak oil. Here's a huge problem that we've basically failed to engage with as a culture, but it's still showing up, and we see it as increasing energy prices. Well, those change the way we behave and what we can do. Well, with these sorts of environmental costs, they'll do the same thing. We'll just have less resources to do other things. So we will continually be adjusting and adapting as things go on. To be aware of what is happening locally is your best bet. If you're going to stay in a region, try to learn what things are most likely going to be occurring in your area so that you can try to set up a more resilient and robust living arrangement for those sorts of changes. But yeah, it's going to be a work in progress. We're learning more and more, but we're going to be on this ride for a long time. You don't have to do everything today or change your life instantly. Ideally, we'd have started this decades ago, as we should have with many of our current problems. But we will adjust and adapt. And just because I or anyone else can't see how we can possibly do something right now doesn't mean that we can't possibly do something. Mm-hmm. Once we actually engage with the problem, there'll be a lot of more creative thought in how do we adjust society and all of our infrastructure to deal with the changes that are coming.
Well, absolutely. And as you mentioned, it will take decades to work through that as well. These are gigantic infrastructure modifications that are going to have to take place, changes in behaviors that span decades, if not centuries, if not millennia in some cases. So this is going to be a big project. It's going to be engaging for a long time. And as you mentioned earlier, whether we choose to engage in it or not, it's with us, and it'll be with us for a long time. Even if we somehow manage to stop all of our practices today, it'd still take quite a while for this to stabilize and settle out. So there you have it. And I invite people again, if you want to discuss more about this, go to the thread. And Mark, it's been a real pleasure talking with you today.
Okay, thank you for having me on.